Hello, hi. Welcome to the another video. As a process of OWASP Docker Top 10, today we are going to discuss about D05, that is maintain security context. So what we are going to discuss in this particular video was what is security context and why the security contexts matter, and how the security contexts work, and some real world examples for security context, and what are the attack vectors and what can go wrong if we are not supposed to maintain a proper security context, and how to identify a weak context and how to fix and prevent the security context, and some overall recap after. So without further ado, let's enter into the video and had a discussion around this. So let me take a pen. Yeah, it is very much like essential and one of the crucial layer for Docker containers, and control what containers can and cannot do. I mean, the security context will decide and control what the container and cannot do, and often overlooked, but it is very much critical for security. I mean, in general, like people often overlooked for that, and but it is a crucial and critical step whenever we are discussing about the security context. Okay, first of all, let us discuss what is a security context. So a security boundaries that controls container permissions. That means a security context will define a limits of what a container can do. It's like a one sandbox that restrict the access to a sensitive system functions, and user IDs as well as group IDs who the containers can run as. I mean, the container is running whether a root or something like that. That means you can specify which user or a group the container should run under. So running a container as a non-root user will reduces the risk of privilege escalations. The next point was capabilities. So what functions, I mean system functions are allowed. Here the in Linux capabilities that will lets you to fine tune the permissions also. You can drop the dangerous ones like net admin or system admin to prevent the misuse of those. And next point was file permissions. What files can be accessed. So security context control some read write access to your files. So you can restrict your containers to read only mode, and read only like specific volumes attached, or we can specify a directories also, what uh, directories and file systems you need permissions. And the last point was system calls. That means what the containers can request from kernel. So by using profiles like Seccomp profiles, you can block a system calls that contain, I mean, what exactly the containers should use, like mount or kill or pt race. So these are the some commands where uh, the systems will use. Okay, so this is what exactly the security contexts are. Okay, yeah, for a simple understanding, think of it an ID card that says you can only do this particular things. Okay, it's just like a employee badge, or that will basically limits the access to a certain like ODCs or rooms. A security context in such a way it will limits what a container can touch, or what a container can execute. I mean, within that what it can do, what is the maximum limits like that. Okay, so that is the one. And moving to the next slide, where we are going to discuss about why security contexts matter. So containers escape prevention. So this was one of the important reason where I mean, what exactly the container escape prevention was. It will stop the container from the breaking out. Okay, so I mean, you may heard in the earlier our discussions run C, where it will exit from the containers. Okay, so basically we can stop the containers from breaking out. Okay, so we can avoid this, okay, by using a security context. Basically security context will help the containers, they can prevent it from accessing a host resources, or escaping it into some underlying systems also. And the second point was privilege escalation. So that means it prevents a gaining root access. Okay, like parallel escalation. Okay, parallel like escalation gaining, or parallel access like that. Okay, by restricting the user privileges, we can stop the attackers from elevating their access inside a container. That means non-root user is not equals to no full control. Like that we can set up. Okay, and host protection, that means we can shield the server from container attacks. So if a container is compromised, a strong security context that will limit the damage of the compromised container. Okay, so it acts as a barrier between the container and your host machine, so there is no need to worry for like further I mean, if one container was compromised because of that barrier. Okay, and the next point was compliance. That means many regulations require proper context. Okay, so especially the standards like PCI DSS, HIPPA, and OSI 27001, that will expect a containers to run with least privileges and proper isolation mechanism. So security context will help to meet these particular requirements. And the last point was defense in depth. That means additional security layer will be provided beyond the images. Okay, so even if your image is secure, runtime behavior will matter here. So the security context add another level of another layer of protection. Okay, another level of protection we can say. So it is like a firewall for a container actions. Okay, so this is why exactly the security context will matter. And now we are going to see how security contexts work. Okay, so here is the some of the examples you can see. SELinux, which is mandatory access control for Linux. Okay, uh, these are the some capabilities or features we can say how the security contexts work. Some examples. Okay, so SELinux enforces a strict access rules between the container and the host resources. It will labels the processes and files, then it will also blocks the unauthorized interactions. And the next point was AppArmor, application security profiles. So AppArmor is used, that uses a profiles to define what each container can do, like which files it can read or what network access it has. It's a very lightweight and easy to apply AppArmor. Okay, and the next one was Seccomp. Okay, so it is for system call filtering. It restrict when system calls a container. Uh, containers can make. Okay, so you can block the dangerous calls, especially like mount, uh, ptrace, or kill, to reduce the risk. Okay, and the next command, next use case was use option use namespaces. That means we need to isolate user IDs. So user namespaces map a container users to a different host users. Even if a container runs as a root inside, it doesn't get a root access on the host machine. So with the help of namespaces we can achieve that. So that is also one of the security context. And the capabilities, that means fine grained permissions will be providing with the help of capabilities in the sense of providing a fine grained permissions. Especially the Linux capabilities let you to drop a specific privileges instead of full root access or permissions. You can allow only a specific permissions what exactly we need, like networking or some file access or whatever the access. Okay, capabilities level. And the next point was read only file system. So basically this will prevent a modifications. So making the root file system as read only, it will stop your container from changing the file systems. It's a simple feature, but it is a very powerful way to block the to block tampering. Okay, and here is the one of the example use case where basic security context will be provided or achieved with this. So this particular docker command runs the container as a non-root user. That means a UID 1000, that means other than 0, and it will makes the file systems in read only mode, and it will drops all Linux capabilities from maximum isolation, for providing maximum isolations. So this is the command docker run -fn user and group ID and read only. Sorry, not a group ID, it is a user ID specifying in a container and assigning to a host, and we are going in a read only mode, and we are dropping all the Linux capabilities, and this was the container name. Okay, so that is how the security context exactly works. And here we are going to see as one of the example for security context with a real command. Okay, so here is the one of the bad practice we can say. That means running as root with all privileges. So this was the command docker run -d my app. This was a basic command. Okay, this particular command runs the containers with the full root access and all the capabilities. It is very risky because attackers can exploit this to escape the containers or damage the host system also. Okay, and the good practice was we need to make sure to run as non-root user with the drop privileges. Okay, so this was the command docker run -d. Let me explain first and then we will go with the arguments. Okay, so this particular docker command applies a multiple security context protects protection for security context maintenance point of view. So it will runs as a non-root user. Okay, we are specifying a user which is user id 1000, which is a non-root user, and it will drops all Linux capabilities. -cap drop all, that means it will drop all Linux capabilities, and it will adds only net bind service to allow binding to low ports. Okay, so this is the argument we are passing -cap add net bind service, and we are using read only file system mode. Okay, and then we are preventing a privilege escalation with -no new privileges. Okay, -hyphen security -opt we are setting as no new privileges, and finally the container name. Okay, so this particular command is a good practice which drops all capabilities and uses only required functionalities or capabilities. And some of the best practices was we need to make sure to always run as root user. I mean, already we covered in this particular like command. I'm just a kind of a recap for this. Okay, and drop all the capabilities and add only which we actually needed, and use read only file system whenever it is possible. And moving to the next slide, where we are going to discuss about attack vectors and what hackers exactly try. Okay, what they use. Okay, container escape, that means breaking out to the host system from container. So attackers exploit a weak isolation to escape the containers and access the host system without proper like boundaries. They can run commands directly on your server, that means host machine. And the next point was privilege escalation. That means they can gain a root access from limited user. Okay, if a, let's say if a container runs as a root or having a excessive privileges or permissions, attackers can elevate their access and take a full control of the host system also. And the next point was file system access. That means read write sensitive host files. So I mean they can they can achieve this with the help of file system. Okay, so file system was the attack vector here. So they can, I mean, if there is a misconfigured mounts or permissions, that will lead to expose host directories, and attackers can read the secrets and modify the configuration files or even delete the critical crucial files. And the next attack vector was capability abuse. So they can use this attack vector, and they can use excessive permissions for attackers. Okay, so containers with too many like Linux capabilities can misuse the entire system functions. So we need to make sure provide required and like necessary capabilities only. And the next attack vector was shell injection. That means this will execute a commands via a weak context. Okay, so let's say if a container allows a shell access or runs unsafe commands, attackers can inject malicious code, and that will pivot deeper into your infrastructure also. Okay, and the final point here was without a proper context, container is equals to root access to your host system. So security contexts are your last line of defense. So without them, a compromised container can become a full blown service breach also. Okay, so make sure to maintain a security context properly in your system. And here we are going to discuss some impact. What can go wrong if the security context is not maintained properly? Complete host compromise. That means attackers own the host server access. Let's say if a container runs with a weak or no security context, an attacker can break out of it and gain a full control of the host system, and they can install some softwares, or they can steal the data, or they can shut down everything. Okay, and the next impact was data breach. They can access and of all host data and other containers data also. Okay, let's say once attacker inside your host, attackers can access some sensitive data or environment variables or even other containers running on the same mission. They can access and they can store the data. And the next impact was service disruption. They can shut down or modify a critical services. So I mean, there is a high chances of attackers can stop the services or reconfigure the services. Uh, they can crash the applications or redirect the traffic that will cause a downtime or chaos for users and teams who are using them. And malware installations impact. So that will, I mean, with the help of backdoors on the host, they can install a like crypto mines or some backdoor activities uh, can be performed and with the help of automatic robots also. Okay, so that is the point. And the next point was compliance violation. Uh, I mean, let's say if the compliance was violated, the regulatory fines and legal issues need to be like taken care. Okay, so a breach will obviously cause a poor container isolation, can lead a kind of non-compliance with the standards like PCI DSS, HIPAA, GDPR. So that will result a heavy fines and legal consequences also. So the final point here was one weak container is equals to entire infrastructure at risk. So all it will starts with a one misconfiguration in a container to open the door to a attacker to enter and like impact all these things. Okay, so these are the impacts or what can go wrong if security context is not properly maintained. And here we are going to see how to identify a weak context. Okay, we need to make sure to check a running containers first. So this was the command docker ps -print -table. It will gives a lists all like active containers in a clean tabular format. This will basically helps us to spot long living or suspicious containers very quickly. And the impact, okay, sorry, inspect container security settings. That means with the help of this particular container, if the containers are running as a root user uh, or has any dropped privileges or that uses a security options like no new privileges and this was the one of the command which acts as a first line of defense. Okay, and the next command was process for root process, sorry, check the process for the root. Okay, so with the help of this command, this particular command will reveals if any process inside a container are running as a root user. If you see the root here, okay, so this is the command docker exec container name and ps and aux pipe grep and root. This was the keyword. Okay, and that will be highlighted and you can catch that. Okay, and these are the some red flags. That means user which is a root and no hyphen cap drop, and if we need to make sure this particular argument is not used. Okay, and privileged mode. Okay, so these particular settings will give a containers too much powers or access, and that will increase the risk of escaping or escalations further. Okay, and the next point was use security scanners. Tools like Docker Bench, Clair, Trivy. This will basically automatically detects a weak context or misconfigurations, and regular audits. So basically what exactly regular audits means, we need to check all running containers monthly. It will makes a kind of habit where with these particular audits we can ensure you can catch a weak context before attackers can do. Okay, attackers before find out, we can catch from our end and we can patch it or fix it. Okay, and the next point was how to fix and prevent. Okay, so if you see here, these are the some best practices we need to be followed. So always use non-root users. That means we need to run a containers with a dedicated non-root user using a hyphen user flag. This will particularly limits what the container can access and prevents a privilege escalations. And then another best practice was drop all capabilities first. So we need to start removing all the Linux capabilities by using hyphen cap drop all. This will basically adds only removes all capabilities, and if we need, add necessary capabilities only. And then we need to use read only file systems. So by applying our read hyphen only argument, that will prevent the containers from modifying the files. This will block a tampering and adds a strong layer of protection and enable a Seccomp profiles. So by using hyphen security hyphen opt, Seccomp is equal to default or else a custom profile that will basically restrict certain dangerous system calls. This will limit what the containers can ask from the kernel. Okay, and this was the things need to be avoided, and this was the things need to be followed. Okay, and the avoided things was never use hyphen privileged. Okay, so this basically gives the containers full access to the host uh, equivalent to a root system. Okay, root user. It's a major security risk, we can say. And the next point was we need to make sure don't run as a root. Okay, so we need to make sure root is id need to be other than 0. Containers running as uid 0 can easily escalate a privileges and compromise the host system. And we need to avoid hyphen cap hyphen add all. So it will basically provides all defaults default all capabilities by default, and it will like privilege escalations may need. Okay, and we need to make sure to avoid it. And no hyphen security opt is equals to AppArmor colon unconfigured. Basically this will disable AppArmor protection, leaving the container exposed. Always use defined profiles. Okay, not this particular thing. Okay, and moving further, where we are going to discuss a kind of a recap whatever we have discussed and the key takeaways out of it. Okay, so security context is equals to container ID card. Okay, what can access what. Okay, and it will controls what a containers can do. Okay, and not what can access what basically what inside a container, what the container have your capabilities to do. Okay, think of the security context as a digital ID card. They will define what each container is allowed to do. It is just like access badges in a secure building. Okay, already in the first or second slide we have discussed. Missing context is equals to easy host compromise. Always configure like missing context. Okay, if you skip security context, containers can run in a wild manner. That opens the door to a privilege escalations, data breaches, or full host access also. And use hyphen user hyphen cap drop is equals to all hyphen read only. Uh, it is like a security baseline where these particular three flags form your minimum security setup. Hyphen user that will uses non-root user execution. Hyphen cap drop all that will remove your dangerous privileges or access. Hyphen read only it will locks the file system against tampering. Okay, and the next point was the regular audits with the Docker inspect. That means we earlier slide we have discussed where with the help of Docker inspect or with the help of some tools incorporating or integrating into a CI/CD, we can regularly audit them and review the like health checkup for the containers. Okay, and the next point was the defense in-depth approach. So multiple security layers will protect in a better manner. So security contexts are one of the layer. So combine them with the image hardening, network policies, and runtime monitoring for full protection. Okay, and the final last one but not the least one, and remember secure by default but not secure by accident. So the security should be intentional manner. Okay, so every container should be locked down from the starting itself, not patched after something goes wrong or something identified or some attackers breached. Okay, so yeah, these are the things we wanted to be discussed in that particular video. And I hope your time is like properly used and something new learning was done. And yeah, thank you so much for being in the video.